All right, welcome everyone to class 3 of the Cloud Engineering and API Cloud Solutions and API Integrations class in Omaha Data Science Academy. My name is Jeremy Bergman. I'm the instructor for this class. And tonight we learn about one of the first main components of the cloud data engineering platforms or data services and infrastructure. This will be cloud storage and databases. So over the years, new storage techniques have been created for large, either large data sets or like a wide variety of data sets. Like data sets are being, and data is being used in completely different ways than it used to be. So often in the old days, it's mostly structured data. It'd come from database tables and systems or tabular data of some type produced by a system, or maybe it's a financial analyst doing some analysis in Excel. But nowadays, especially with machine learning models, people are doing things like image recognition, real-time sensing with IoT, Internet of Things, analyzing text, building large language models. So they're using all types of what we call semi-structured and unstructured data sources. So we're going to cover some of the new forms of cloud storage that handles that type of data. And then we still cover databases because a ton of data is still produced by systems and structured data. If you think about a business, most people do their work within some type of system, whether it's a CRM, an ERP, HR systems of any sort. So there are people constantly working in systems and entering data, even worked in hospitals where you're like booking procedures and then you're doing billing and accounts receivable and things out of it. So all of that still exists plentiful in nature and still often stored in relational databases. But you'll also learn some alternatives. They're usually like unique use cases where you'd use some of the alternative databases. We'll learn more about those. And like I said, as a data engineer, I wouldn't expect you to be an expert out of certain things in this class, like being like a GraphDB, NoSQL expert or anything, no matter how many job postings ask for 10 years of experience and something that hasn't existed that long. It's more about, as a data engineer, knowing what the use case is and when you could use a certain tool or storage for to make your life easier, to make managing data at scale a lot easier, which is one of the main roles of a data science or data engineer also. All right, so that's what this class is all about. Okay. So how's this class structured? I posted the quiz one out there. Feel free to finish that at any time. If you miss any questions in that Google form link, it'll give you the answer, but I'll provide the answers after I know everyone's taken it after class. We'll do a brief overview of last week, the content covered. I think I'll do that each Monday instead of doing it before each class, since we have a lot to cover in these classes. I'll do just a brief recap on Monday of the previous week. So in this first hour, we'll also take an initial look at those cloud storage services, particularly Data Lake in Azure. That's named Gen 2 Storage. We'll look at some of the unique features of that handle the data that I talked about. In hour 2, there's a new type of architecture called Delta Lake architecture. We're going to learn more about that. This is really to help with data warehousing efforts and be able to incrementally continue to add data to data sources. It's pretty new, fairly new concept, but it's a really good tool to have as a data engineer to be able to continually to incrementally add to an existing data source in an effective way. So that's a simple description. We'll dive more into it the second hour. And then we'll have a pretty good overview of all the Azure cloud databases. And it'll be more of an overview, and we'll set up MySQL Azure database in the hands-on exercise. But we won't go too much detail into it other than knowing that they exist and what their purposes are and so forth. Those are always things that once you know, I'm a big believer of. Once you know something, and if you need it, you can dive deeper into learning those technologies. And then the hour 3, we'll have hands-on. We'll do an exercise where we take data out of cloud storage, and then we start to implement Delta Lake, a Delta Lake architecture implementation, which in the next class, then we'll start processing some of the data and then really start to fill out the implementation. And that will be a big part of that will be primarily what you do in your second homework. Okay, so week 1 review. I'm gonna go through this really fast, but I did create a bunch of notes here in the notes section of the slide for you to review. I just elaborate on each one of these bullet points, and you can read it, but I'll cover it here fairly quickly. Just to recap everything that we accomplished last week. Give me 1 second, I'm gonna drop this into Notepad. Back to that slide. Okay. Okay, so so we covered the very beginning of class, like what is cloud data engineering in data science, and what's the role of a data engineer and why is it important? Data engineer is really that professional who designs and builds infrastructure for data at scale to be able to manage either large data sources or a wide variety of data sources that we talked about. And then what the cloud platforms do is that they give you a platform as a data engineer with many tools that you could use for those purposes to manage and scale and build repeatable processes. So the main components of the cloud data platform, we covered that right before we went online, but we'll really be diving into those the next 4 classes. Starting with this class, we'll do storage. Next class is processing, and then compute. So processing is like, how do you take and extract and load all that data? How do you do the heavy lifting? Compute would be like breaking it down into smaller pieces. Like, how do you manage large data sets and do real-time analytics? And then machine learning and AI, like deploying those type of solutions through this entire process. Okay, we compared cloud services. They have a lot of similar features, but they're just a little bit different in their strengths and weaknesses. And one of the things I'll be asked on the DP 203 exam is understanding the difference between infrastructure as a service versus platform as a service versus software as a service. In particular, which one is like the most hands-on or hands-off approach for an administrator? So oftentimes software as a service, that's managed by someone else. That's why it's so attractive to people, is that a lot of software as a service platforms, it's an e-commerce website or some type of other startup or application or mobile web. It's really managed by that company and provided by users to use. Then platform as a service is somewhere in between. Azure tends to be platform as a service. Like we did in the first class, we configured those services a little bit. But the platform service, those main platforms like AWS or Azure, they still manage quite a bit of like security and network or security patches or vulnerabilities or software upgrades or configuration. So that like can't be underestimated on what the platform provides you. You could spend all your time as a data engineer trying to like manage your own databases, especially those ones that are like NoSQL databases. The cloud platforms help you do that. Then infrastructure as a service, this is almost all compute. So this is like providing you the processing power to be able to do whatever you want with it. So that's like running a website or doing a virtual machine or something like that. So that one's the most hands-on because whoever's doing that work, whatever architect or engineer, they're administering like a virtual machine or something like that. But somebody like Azure is providing the processing resources for it. So it's up to the engineer to be able to configure and everything there. So I'd say from as far as hands off to hands on, it goes software as a service, platform as a service, infrastructure as a service. Okay, so and then we did a little bit of Microsoft Azure Data Services, just that big picture overview of Azure as a big ecosystem of applications, not even all of them necessarily related to data. So a lot of development side applications and integrations, but our focus is on, for this course, is on the data services in Azure. Okay. So in the second class, we covered APIs and data science. So we defined an API as an application programming interface. That is really an interface that allows a system or two systems or software to be able to communicate to each other through a common language or interface. So like a REST API would potentially communicate back and forth via JSON. One would, you would send a request, the server would process it, that end server would process it, return you the information that you're requesting. We took a deeper dive. Well, the importance of APIs in the data science is that it's mostly retrieving data, not quite as much as doing operations or things on a remote server like we did with the box platform in the hands-on exercise number 2. But more in data science, it's about automatically or programmatically getting data. So automating those type of workflows that you're able to go out and get new information or real-time information and so forth. The different types of APIs, we discovered a bunch of them and their use cases, with generally the most popular one being REST API. We dug deeper into that, the different operations, their CRUD operations. So create, read, update, delete. We have your gets, your puts, your posts, and your delete operations. We briefly covered authentication methods. In that walkthrough, I go deeper into OAuth 2. OAuth 2 is like the most secure, but the most complicated form of authentication. But ultimately, what all APIs do is they create some type of API or API key to determine what type of access you should have to those resources or endpoints. So not all of them are as secure as you'll see with the Coin Market Watch API. They just give you a key and then they monitor your usage and trust you to use it effectively. Whereas bigger systems like Box, there's a lot more potential for doing something that isn't secure or deleting things that need not be deleted. And then you could really put some security controls around it. That's often when OAuth 2 is used more when you're accessing a system like that. And then we did a process of working with REST APIs. I updated it to a 6-step process that starts with reading the API documentation, identifying the endpoints, understanding authentication and getting the access tokens that you need, or API keys and access tokens, and then the request and response process all the way to parsing that final result, which is often JSON, but doesn't always have to be JSON, and handling that appropriately. Yeah. Covered a lot there in week 1. That was quite a lot to recover in 5 minutes. I just wanted to recap where we are and where we're headed. All right. So class 3 objectives. So we're going to overview cloud storage solutions. We'll do some different storage types, hot versus cold. Some things that are important to know as a data engineer. Public versus private, what's the difference? And then blob storage versus other types of storage. So like what different types of storage are available. And then what is a data lake? So over, I'd say like the last 10 years or so, data lakes have become really popular for the reasons I said on the first slide. I overviewed on the first slide. It's actually handling a wide variety of data sources. The data lake is a type of storage, and it's really generally type of blob storage, but these platforms have optimized it for handling and storing and managing data sources. And we'll see that when we dive deeper into Azure Data Lake Gen 2 storage and how that differs from blob storage. So blob storage is really, I guess it's almost like it sounds. You could put basically anything in there, text, files, binary 1 and 0s, like application data. It's really like a big storage bucket or blob. You could put images in there and so forth. Pretty much anything a computer can store. And then data lake storage is optimized for the types of data sources you generally use for analysis. We'll see some of those optimizations. Right, so introduction, and then we'll cover cloud databases. Just want to give you the landscape. This is pretty good overview of the cloud databases. So Azure SQL, this is Microsoft SQL Server, MySQL, Postgres. Then we have some NoSQL DBs in Azure Cosmos. MariaDB is actually itself a relational database, generally used for applications. And then we have Synapse Analytics, which we don't cover a lot in this course, but it's the analytics big data platform Microsoft created. And then your data lake and your types of data storage within the data lake. And we'll see when some of these are the most appropriate to use. And then even your managed disks. Okay. Then the last point is we'll cover some data lake tools. So some things that you can use in conjunction with working with data storage in Azure. And hold on, I need to plug in my laptop before that happens. And then I don't have Delta Lake on here, so we'll cover the concept of a Delta Lake and kind of like that new technology and what the best uses are and how it's being used as a new transactional data source, kind of like a new supplement to the traditional data warehouse in business intelligence, just in general. And let me make sure I get this other end plugged in. Okay. Class 3 objectives. Okay. So what is cloud storage? I think you have a pretty good feel for it, but it's a mode of computer data storage, which digital data is stored on servers in offsite locations. So think of a public cloud or a big one like Box or Dropbox or something like that. I'd consider them cloud storage, in particular like public cloud storage, where multiple customers can use the same storage. But they're always like offsite. That's like what they always talk about being in the cloud. So like even OneDrive or Google Drive or something like that, it's not physically on a hard drive on your computer. It's a bunch of managed resources, storage, or computer, something else, which is completely offsite. In particular, cloud storage is managed offsite. They're managed services by someone else. They're always maintained by a third party who's responsible for the hosting, managing, backing up, and securing data stored on its infrastructure. I'm actually glad that there's a cloud because, if you're storing a bunch of stuff on a computer at your house, if, lightning forbid that lightning hits it, or there's a huge surge in your house and, it wrecks your electronics. That's happened to me before. This provides like backups. And it's generally more secure in the sense that these cloud companies are really focused on secure. They have whole teams managing them. Doesn't totally mean that they are, but in general, better than you managing security yourself. I mentioned some of those examples. And Microsoft Azure, GCP, and AWS, they all provide enterprise storage solutions and ecosystems for applications and data management. So even with applications, it's important. They generally have blob storage, some efficient blob storage, and they use backend databases. The applications are storing data in real time. Those web applications or cloud applications, oftentimes they're software as a service. They all have resources for that. And then they also have these storage solutions specific for data. So advantages of cloud storage, it's a lot of what we saw at the beginning of class, like what's the advantage of cloud and why cloud engineering. So you save space on your own computers. You have a very low maintenance cost in general. Little to no technical knowledge, especially with like Google Drive or Dropbox. It's just almost an extension of your hard drive or your operating system that you have on your laptop or desktop computer. Security, you can access it from multiple devices. So that's really nice, is that I could put pictures on my computer and access it from my cell phone. Scalable, probably the biggest one, or maybe the biggest one. Prevents data corruption through backups. And then it's pretty easy to upload and download data and manage data in the cloud. Even with data lakes, they intentionally make it easier to manage than it might be otherwise if you're doing it on your computer and managing file versioning and folder structures and things like that. Okay. So terminology, like to do this for any time in introducing a new concept. I talked a little bit about public cloud and private cloud. Public cloud is a service that's offered to multiple customers. This would include Azure and Box. There are multiple companies or personal users on those services. It's operated by a third party, and those resources are shared by a lot of users, whether it's a big company or a private company, or a private party, or just a person like me or you. Private cloud is dedicated solely to one organization. All those resources and storage and everything, it's hosted by somebody else, by a third party, and you don't do it yourself. So one of the most, in IT, one of the most common things is like a managed service provider. That may not be that familiar, but often companies will outsource their IT teams to another company to do it for them, and they manage it instead of having to have your own tech resources yourself. So eventually there's usually some type of breaking point where you're paying them, but you could just pay a full-time person to do this yourself. And there are always trade-offs and considerations. But private clouds can be useful, especially if you just need something that meets your own company's demand. It could potentially be cheaper. Really all depends on the setup and everything and the services that you're getting from managed service provider. But Azure also has this. Azure or Microsoft will come and consult with your company and do a solution. Potentially that's a private cloud solution. So they'll dedicate resources just specifically for you, and like an account manager and everything like that. So they have some of those capabilities too. Hybrid cloud is a mix of on-premise, private cloud, and third-party public cloud services. This is the most common in enterprises now, the hybrid cloud. So often they have a bunch of legacy systems that they're managing themselves, but they're migrating to a cloud, or they're part of the way there, or they just want their data in the cloud for data analytic purposes or machine learning or whatever it be. Hybrid cloud is really common solution. And Azure, that's one of the big benefits of that, is that Microsoft Azure offers a bunch of services around hybrid cloud. So you may find yourself as a data engineer extracting a bunch of data from your systems, like on premises. So on premises means inside of your own company. And then you're just extracting that into the cloud for use within cloud services. Really depends on your setup, but it's very extremely common, especially where a company exists and they're moving their services towards the cloud. I want to cover hot and cold storage too. So if you think of this as like computer memory, hard drives are the same way. So you have cold storage and hot storage. So cold storage would be data that you use less frequently. It's cheaper because it doesn't have to be as readily available. It doesn't have to be like on as fast of hard drives and accessible. So they call it cold storage. Hot storage is the opposite. So it'd be stored where it's easily accessible and on faster hardware, particularly disk, and maybe sometimes even memory, like RAM, stored directly there. It's more expensive, but if you need applications that respond like super fast and in near real time, e-commerce websites are often like that. A lot of their storage, they'll use some type of hot storage for that data. In data analytics, not really as much. You're usually okay with cold storage because you're running these processes like daily or weekly or maybe a couple times within the day. But you can have certain things where you're doing near real-time applications where hot storage would make sense to do that, especially if you need like an operations dashboard that's really fast and responds super well. So knowing that both of those exist, and there's a whole range. It's not just one or the other. There's a range of hotter storage or colder storage and different options, just like we saw with processors and memory when we were setting up Databricks. And then last, here's the direct comparison between the storage on AWS, Azure, and GCP. And I think all the advantages of each one of these cloud platforms hold true. Is that AWS is like the applications or enterprise, the applications grade storages. They have like simple storage and your elastic block and your blob storages that are super fast and are particularly good for disaster recovery. GCP is like analytics, super highly optimized their storage for machine learning and AI. So they have just regular cloud storage. Infrequent storage or different types of file storage and backup and so forth. Azure's really like that enterprise grade that's highly integrated. So these type of things are highly integrated with like your OneDrive or Microsoft Office and like your existing security protocols that your existing security, Microsoft security, you have an organization like Active Directory or there are a couple of different ones. Forgetting the acronyms now, and then not too important. We'll cover it near the end more about security as a part near the end of this class too. But Azure is like highly integrated with like your existing Microsoft infrastructure and setup if you're a Microsoft organization. So all of those still hold fairly true. Okay. So that's cloud storage terminology, getting familiar with those. You will be asked about the DP 203 exam, covers those. Okay. So Azure's data storage services, so diving deeper into Azure. We have a few different types. Generally, the most typical ones are file storage. I didn't realize Microsoft is spelled wrong there, but you have file storage and disk storage, your typical storage. And then with your data services, you have Gen 2, which is a type of data file storage, and is your data lake. And then you also have these alternative data structures that are useful oftentimes for storing data. So you'd have a table storage, and that's like you'd think you could store tabular data in it fairly easily. You have a queue storage, so if you think of a line and like a first in, first out, or last in, first out, that type of data structure, really important in real-time streaming and like how you receive data and then how it's processed, the order that it's processed in. And then blob storage, which is just a specialized type of file directory or storage. So file storage is more like your traditional Windows Explorer or something like that, your file storage, where blob storage is a little more for like applications or images, text, pretty much anything else a computer could produce and store. So diving a little bit deeper into these. Excuse me. All right. So Azure Blobs is a massively scalable object store for text and binary data. So I put Data Lake Gen 2 here because Data Lake Gen 2, as I've mentioned a couple times, is Azure's version of the data lake. It's a blob. It is blob storage, but specialized for data processing, data storage, and data processing. So you have Azure Files. You can manage file shares for cloud or on-premise deployments. You could think of this as like OneDrive, but they also have their own private services that you can use. Don't really use it. Don't really use it for data services, just knowing that it exists in Azure. Perhaps an application is storing logs within file storage that you could access within the organization, and then maybe you move it over to the data lake Gen 2 or your storage Gen 2, and then process it for analytical purposes. You have queues, like I said, message store for reliable messaging between application components, especially real time where order is important, and tables. So it's technically called a NoSQL store for schemaless storage of structured data. So when I teach SQL 101, we talk about like the different properties that make for highly structured data, especially like those that are first normal form. So like all of your columns have different names, all of your rows are unique, the order of data doesn't matter, and so forth. What Azure Table is it's that type of tabular structure, but instead of like column based, it's often like a row based structure. So if that's confusing, I think we have an illustration of it, but basically oftentimes you'll receive transactions, and say you have 10 columns in your table, but that transaction only has information for 6 of them. So it'll match those columns across the rows. And then whenever you reference by column, you'll be able to get all of the transactions. But maybe you get transactions with 10 of the columns populated, and some of them have 7 or 8, and then you get that one with 6. So it's a more flexible version of the highly structured database, relational database tables that you create. You don't really have primary keys or anything like that, no key components, or you don't really relate it. You're just storing it in this table, and we'll see why that can be really beneficial, especially when you're pulling data from REST APIs, and not all the information won't be there necessarily for all of the columns. It gives you a really flexible table type storage for data that's really useful for data engineers. But we'll take a closer look at. So what is a data lake? Covered this a little bit, but data lake is a new type of storage specifically for data. It's a centralized repository that ingests and stores large volumes of data in its original form. So an original form is a really important point in a centralized repository. So if you imagine all of the data that a huge organization could produce. They will produce web logs from their websites, their applications on websites, XML, CSV, text files, people working out of Excel sheets or OneDrive, Excel and OneDrive, or Google Sheets or something like that. It's like semi-structured data. Organizations want to try to make use of all of these different data sources, and you can imagine like how difficult this could be to manage on a huge scale. They want to bring in some real-time data. One of the examples I've worked with in the past is worked with someone who did machinery. They do plastic molds, Airlight Plastics in Omaha, Nebraska. They have a bunch of machinery that they monitor real time for any type of failures or overheating and things like that. So they're constantly streaming data into a data lake themselves to be able to, and then running it through models to be able to try to predict ahead of time which machines need to be fixed or shut down temporarily and so forth. You could have all these social media sites. That's where REST APIs really come in. You connect to, not Twitter anymore. Need to update my site slide, but Facebook, Instagram, YouTube. No more Google Plus either. This one is kind of an old one. But Messenger, anything like that. Bringing that type of insight in, this crypto API, if you're so inclined, you could bring in news and sentiment data to be able to help with predictions. Then your traditional databases, these are data warehouses or data marts, or maybe another application database like SAP database or whatever applications you're running. So you have huge volumes and a very diverse set of data you could potentially use in the same organization. And then the question was, well, how could you even manage it at that scale? And the data lake is how you manage it all from a storage perspective. So difference from a data warehouse in that the data warehouse stores structured data, analytical data. I cover that in my MySQL 101 class, like your online analytical processing. All that's like cleaned and transformed and exactly the way you need it for reports and dashboards and everything like that. This differs because you're really just storing the data and then you're trying to figure out what to do with it later. Oftentimes it's not as important, or you're just trying to figure out a way to capture semi-structured or unstructured data that won't go into a typical data warehouse or relational database. That's what the data lake's for. Talked about ELT versus ELT. ELT is becoming more common. So oftentimes you're trying to capture these data sources and you're just trying to do that. And then you aren't exactly sure what you would need them for necessarily, but you know you want to capture them. And then you want to define those business rules or transformations later. This provides for a really flexible way of doing things instead of always having to structure and transform like every single data source you come across. That can be a huge effort with huge enterprise teams. ELT gives you more flexibility to determine, need to caffeinate up, determine what you do with the data later and all the different transformations that you need. So oftentimes you store these in what you call a raw data format. So exactly how it came out of the data source. And then you define all your summarization and cleaning and transformations later that you need for models or dashboards or for key performance indicators or business metrics and so forth. Use cases, machine learning is a huge use case for it. You imagine one that does image recognition or some type of real-time IoT. For predictive analytics, be able to store data over time. AI, and then real-time scalable analytics. So trying to find a place to store these massive sources of data, real-time data, can be challenged. Can easily scale up and down as you need, or just undefined data or text data. Text data, super common now with large language models and AI. In the past, they've got the disciplines called natural language processing. You would take it and draw insights or predictive models or inference off of text, which is basically what a large language model is. But being able to store that data and then transform it through a machine learning pipeline for the type of data that the machine learning model needs or the large language model needs to be able to classify documents, document classification, and to build those models and refine them. Even text data is being used in those. So data lake is that super flexible blob type storage for analytics. So I'm going to cover these before we go on break. So data lake storage Gen 2. It's built on top of Azure Blob Storage. The key features, here's a key point for the exam, is it's a hierarchical namespace. So organizes files and folders in a more efficient manner, like a traditional file system. So within a given folder, I have my Omaha Data Science Academy folder where I store all my files for my different classes that I teach. It is hierarchical in sense, this is top of the hierarchy, and then you can drill down into successive hierarchy. So you have the cloud data engineering, and then within these, you could go to your class lectures. Then I even have like some of my, in other classes, I have some of my saved slides, previous slides. So very intuitive in an efficient manner, like a traditional file system. I think that just intuitively, people have been using computers for a long time. It makes intuitive sense for them to organize it that way. Otherwise, oftentimes blob storage is you just store a bunch of files and you have different containers and store a whole bunch of files in it without that namespace. But you can imagine if you had hundreds of files and you're trying to find a spreadsheet in that or Excel file, it helps for just that systematic organization. It has high scalability, supports massive scalability requirements of big data analytics. Can store petabytes of data with these. So just like that, an engineer can configure it for hot or cold storage, the availability, or they can define how much storage they need. Always expand it up or down. And then highly integrated with analytics services. So highly integrated, this is one of the best key features of Azure, is that it's with other data tools, whether it's Databricks, HD Insight would be their big data platform, one of their big data platforms. HD Insight is within Databricks, or Synapse Analytics, which is their own, but it's highly integrated data store with everything Microsoft. So that actually provides an advantage with all this data. If people are putting it in OneDrive or they have all these Excel sheets or everything, Azure has the type of integrations that help making that movement and collection of that data just a little bit easier instead of having to create all of your own integrations. So if you're already highly tied into, as an organization, tied into Microsoft, Azure can be a good solution for it, or highly integrated solution that makes things a little bit easier for the organization. And then this shows how it works. So your end-to-end analytics. So this is a good picture of what we'll be doing in our class. So collecting all these different data sources, your Azure Data Lake goes across, your data processing or ingest. This is Data Factory. We'll learn about that in our next class when we talk about data processing. Prep and train with Databricks. Maybe you store some structured data within SQL Data Warehouse or Microsoft SQL Cloud Database for reporting, and then you present that out to Power BI. This would be like a data ware reporting data flow or structure. But just a pretty good view of like end-to-end analytics like we'll do in our class project. Okay, so table storage. Azure Table Storage is like a NoSQL key value data store that offers highly available, massively scalable storage so that applications can automatically scale as needed. So I said it was a row storage. The table is. It's actually a key value store. So you have these different keys, and then you could reference the key value by column to be able to get the values that you need out of the rows. So it is row-based in the sense is like you're looking for a key, and then you could get your column values out of those keys. I may give everyone a video on how this works, an instructional video. I'll look for one over break. But it's designed to store large amounts of structured, non-relational data. So it's structured in this tabular format, but you aren't relating it together with any other tables. It's meant as purely its own store of tabular data. And why this is useful is that it's schemaless. So in SQL, we talk about your highly structured tabular data having a schema. With Microsoft, with MySQL, we talk about schemas as databases, but this is like schemas as far as your columns are concerned and your data types within it. So whenever you create a table in a relational database, you're defining that data, that column, in a very specific data type for that schema, that schematic or that table schematic. This is schemaless in the sense that it can have a different set of properties. So each one could have, I said, maybe you have 6 out of 10 columns for it, for that call, for 6 out of 10 columns for that record. Or maybe your data types change within it, within the records. So maybe some of them are numeric, some of them are character, and so forth. So it handles mixed types really well. It just basically takes that record and just puts it in here. It becomes very flexible in that way because you don't have to tightly define or like clean and tightly define your data. That's something that you could just store quick and dirty in tabular storage, and then you could figure out those transformations or that cleaning that you need to be able to get that into a relational database table. So it's highly flexible, and one of the things that happens oftentimes is schema drift. So all of a sudden that you'll be getting new data or columns, or it'll end up being named. So like one of these columns change, and then all that happens is that it just becomes a bigger table. It just adds them at the end. And then later on, you can figure out, it captures that schema change, and then you can figure out how you're going to put that into a relational database table. So super flexible. I use it quite a bit. I use it frequently. It can be a step. Like I mentioned, a step before you put it in a relational database table. So you're just storing all this transactional data that's not very structured, highly structured. And this provides a good tabular, flexible data source to do that. And then I forgot to update the queue storage slide. So I'll give everyone a break. I'll give everyone a 15-minute break today. Actually, let's give everyone 10 because we still have quite a bit to cover. Let's give everyone 10 minutes till 7:25. And during that 10 minutes, if you want to take your quiz, you could do that. And I'll get everyone an example of table storage, Azure table storage, and Azure Queue storage, so we can keep moving forward. I'll grab a couple videos. So go ahead and grab a 10-minute break. I personally need a drink and to just get up for half a second. But we'll come back here at 7:26. We'll start at 7:26. All right. See everyone in a few minutes while I grab some of those materials. I'll be right back. Luke, I see that you have a question about tag-based namespaces. I'll check that out over break too.
Yeah, I don't know if you can hear me, but confused. What do you guys have to eat over there in Omaha, Nebraska? Like, what's a famous dish over there?
Steak.
That's it?
I mean, like, sorry, it almost felt like a joke, but I mean, steak in general is big over here. We have any place that'll like serve you a big entree is kind of popular. You know, whether it's an entire catfish or a giant T-bone. I don't know if we have any signature dishes. I just know that we're big in beef and big in steak in general. Yeah, that's the best answer I got.
Nice, yeah. Like we have a Chicago steak seasoning. I'm not a huge fan. Like a little bit simple. I think the simpler the better with steak.
I agree. I like to do at home. I have a seasoning I typically use on a lot of things, but it's black pepper, it's sea salt, and just a pinch of garlic. Just salt, pepper, a little bit of garlic.
I was like, you better not say Danos.
No, but I mean, I've tried a bunch of different products, so unless I want to go like Cajun blackened, like I just stick with salt, pepper. Like for most things, heck, sometimes I don't even pepper. There are some things that you just put a little bit of salt on it, and it brings out the natural flavor, and it's great. But
I'm a heavy pepper and garlic guy.
yeah, no, but like here in Omaha, like we have a whole company that's in. I believe it's international. I know it's at least national, but Omaha Steaks.
Yeah, I figured out, but I didn't want to assume like, oh.
Well, I mean, we have plenty of ranchers and farmers and cows, and we're big on the quality of our beef. Like, I mean, as far as a signature dish goes, there's a lot of random companies that use us kind of as experimental kitchens, which sometimes is annoying and sometimes is awesome because, like, the fast food places, sometimes they send us the random dishes before they decide to put them on the national menu. And so sometimes that means we get really cool or really weird things and then they vanish, never to seen again.
Omaha's kind of known for the Reuben.
I was
Arguably.
wondering that. I didn't know if we could take credit for that.
I think it's disputed. I think there are a couple other people who claim it, but I think if we define it right, I think Omaha's the first that had it.
Yeah, because I was about to say if you take out what I said on how we're big into steak and big into like big entrees, the only thing I can think of that I've ever heard Omaha try to take credit for is the Reuben.
Nothing wrong with Reuben. I love a good Reuben.
I love a well cooked Reuben, and I really hate it when people have more sauerkraut than anything else on there. And I also like to toast my sauerkraut before I put it on the sandwich, caramelize it just a little bit. That's where it's at. Heck, I remember as a kid helping out. My dad had a restaurant south of Omaha. And there were just some times of the year where we could get the meat cheap, and then we would just have, it was like a freaking Reuben fest some weekends. And I was just at the grill, toasting, just like, I just have a whole pan of just sauerkraut, put some onions in there, pepper the crap out of them. Then we have another one of just the meat, get the cheese sauteed on top, and then I bread them up, hand them to the next guy to smash and toast, and then just flying out the kitchen. Did so much slave labor as a kid.
I'm hungry now. Reubens and corned beef are excellent on St. Patrick's Day here.
Yeah. And
the food's really good. The restaurants here are really good, but I don't know if there's like a signature either. But there's a wide variety of good food. Like
yeah, I can agree.
Indian or Mexican or.
Well, we got a lot of nationalities around here.
Yeah.
God, I can't get my camera right.
Yeah, my buddy John that lives there, he's like just a huge Viet. Vietnamese community out there where he's like getting pho, um, hot pot. I know sushi's Japanese, but like this guy's always eating.
Yeah. No, I mean, we've gotten more sushi lately, in my opinion. We've gotten some Vietnamese, but it honestly, a 10-minute trip down certain streets, and I don't know what nationality you wouldn't see. But yeah, no, we get a lot of that. But it's also really easy to just like pick a place and get a pound of steak, like a literal pound. Like, how do you want it? I don't know if anywhere else can claim it, but I know when people order steak here, it's not uncommon for them to order it blue or still mooing, or just kind of toast the outside and put it on their plate.
That's too much. I like mine rare, but that's too much. I got it one time blue, and I'm like, okay, send this shit back. I never sent food back, but I'm like, this is too much.
It's like, give it 3 more minutes, please. No, it's kind of common here. I think it's more common in the older generation, but it's common enough. I mean, and it's the same place that if you were to order very well, there's a 50% chance somebody will find you and slap you.
Yeah. There's some classic steakhouses in Omaha. They're classic restaurants, but
Yeah.
I can't think of one signature dish. If you came to Omaha, they're ones that have been around for like generations.
Even the generational ones, like, they keep up with the seasons and they keep up with the trends. And I also can't think of one that's like stuck with a dish. Like, there are plenty of places that are like
Fortunately.
known for their steak or known for their fish, known for their potatoes. That was a fun experience.
Google says Reuben.
Ah. Next time you're cooking a Reuben, just get like
Come to Omaha, get your Reuben.
just get like a pinch of it, just enough to fill up your fingers of sauerkraut. Toast it with a little bit of butter and a whole bunch of pepper separately while you're doing the rest, and then put it on your sandwich. You don't really need to salt sauerkraut, and the butter will help it from not burning, or else it turns into like dried up seaweed. Back to
What's
class.
Do another lecture on places to eat in Omaha. You
Real
can
quick.
never just talk to someone I was working with. We used to go out on Fridays to somewhere new, and you'd never run out of good places to go to eat in Omaha. And you did it like your whole life, every week, your whole life.
Yeah, I was about to say, like I was saying, like, we even got some chain places that change from site to site. But like, if you were anywhere near downtown Omaha, there's 40, 50 places that's just listed on Google, and I can guarantee you there's another 20 or 30 places not listed on Google that you can just walk down the street and just be like, what's this? Walk in, get some food. Like, so yeah, some areas are just littered with it.
Emily and I were talking last week on bringing people in to do lectures live. That would be a way to do it. Just have like a catered banquet of some place here in downtown where I'm at.
A lot of them would jump on the opportunity to cater. That's how you get us all in person to class.
Yeah. I was brainstorming this week.
Alec,
Well,
would you
that's like the
some
most
free Reuben?
just light bulbed it.
What was that?
Would you fly into Omaha for some free Reuben? Make it to
Oh,
class on time?
Well, my buddy's trying to get me down to go to, I guess, what is it called? The Data Scientist of the Year.
Yeah.
He's just trying to get me to go down there, but I'm like, I got kids, wife. Can't just all fly down. I want to. I really want to,
I
He has
get
a
it.
big
I
house,
mean,
though.
maybe you can just all move here.
Tornadoes.
Tornadoes
Oh,
are
by the way, if anyone has a data scientist of the year, feel free to email Nate Watson. That's a reminder that I need to do that too. For upcoming conference hosted by Contemporary Analysis. If you haven't heard about it, I'll drop the link there too.
Yeah. Okay.
But I got to get moving on this. We'll never get through it talking about food. Not that it's at all a bad conversation, but I dropped a few links in here for table storage. So in the last class I taught, we did this in Microsoft Fabric. And it's like an all-in-one platform, data science and data engineering. But we spent some extra amount of time on table storage as one of the big components. And it's actually really huge. It's a really great tool for data engineers to use for that flexible schema. This guy seems to do a pretty good job. It's 22 minutes. He's pretty thorough about it on what is it, how you use it, how you set it up in Azure, and how you query it and everything, and describing it. I had one that was queue storage here also. I thought I pasted it here. Azure, there we go. Oh, it's just not appearing with the link below it, but there's also queue storage too. I haven't really used queue storage that much. That's more for like asynchronous. I haven't really used real time a lot. Really, in my experiences, either a lot of times the regular processing was good enough for what I was doing. Usually it's a special use case to do real time or queue. But tables massively valuable, especially when you are when you're parsing JSON responses and those key value pairs. You can place all those key value pairs easily inside of one of these tables. So it's a good structure for that. Luke, you had a question about tag-based namespaces. I'll get you some more information. I looked it up and get you some more information on it, like defining your namespace through. What were you thinking there? I'll let you.
Yeah, I just I guess I just have been fascinated with tags since I learned about them in the I don't know, 2004, 2005 or whatever. The idea that a thing doesn't have to have a single location. Well, that its location doesn't matter as to how it's positioned. So it can be in many spaces at once. It's very much more efficient than sort of having hierarchies and things, even if you represent it as a hierarchy. And so it just seems to me that it's interesting that I don't see it represented more, but it's also kind of weird and complicated and sort of like theory to practice. Everybody understands what a hashtag is kind of, but I don't think most people grasp how tags are useful in storage. So I was just curious if, in that context, if there was anything useful for us here, or if it's...
I bet there's some NoSQL structure for it, and the table structures. I was just conversing with my friend Claude. And it's kind of like that in a way. You aren't really defining your own tags quite as much, though. I forgot what it said here. What the other response was basically, but there may be some NoSQL data structure that helps you out. That'd be like a one-to-many relationship, I guess. Is that you have multiple tags and then you have one record and then you can store with multiple tags, right, Luke?
Yeah, and I would imagine most of the time you would just write something to manage that, because it would be almost like dynamic navigation patterns. And so that would become something in your structure. And then your file just has a set location, whether that's blob or wherever you're storing your stuff. And then it gets connected to maybe sometimes a hierarchy, but also potentially.
Yeah,
other things.
Yeah, I get where you're going with it. Yeah, that's the whole thing about these alternative data structures, right? Is if you have a use case like that, being able to do it in a more flexible and manageable way instead of like writing these huge scripts or code to manage it yourself
Well,
and the
I think with
relationships or
I think the problem with hierarchy and folders is like it's easy to create duplicates because if you accidentally create a new folder name or whatever, it's a new file. Like the dynamic is yeah.
yeah, if I think of that like a namespace, folders. Yeah.
Sorry.
I'll think some more on it.
Yeah.
But yeah, all sorts of the point is just like how you take this data and like these use cases in different ways and all the different ways organizations want to use it or like applications even how you use it, like how do you store it and manage it in the most effective manner. Okay, so we're gonna start playing through this. The guided exercise is gonna take a while, so I'm gonna move through this fairly quickly. But Delta Lake architecture is one of the concepts we're gonna focus on for our class project in designing this Delta Lake architecture. So it's in the DP 203 exam. I'm relatively familiar with it, having done Fabric, the lab, Microsoft Fabric, last semester that I taught this. So Microsoft Fabric is like that all-inclusive data engineering and science platform. They talk a lot about, they have an integrated data lake and Delta Lake architecture tables and Delta Lake architecture that they're really huge on. But it's relatively new, this Delta Lake architecture. So the idea of it is having this storage, I'd almost call it like a cube-like storage or multi-dimensional storage where you can incrementally continue to add new records or observations to it. And you can do all those operations like create, update, insert, delete, and even they have like upsert, which is update or insert operations. So it's like a new super fast, lean version of kind of like a data warehouse, but I'd almost think of it as like a data cube Tableau. So you create like a Tableau extract and you can incrementally add records to your data extract, or it's like a container or cube that you can use to continue to store as new data comes in, continue to store that data. And then it's a highly efficient data source for processing data and analytical purposes. So that's kind of like the definition of, there's a format called Parquet that you use for Delta Lake architecture. But the Delta Lake itself is like a storage layer for enhancing that reliability. It acts as a bridge between traditional data warehouses and the raw data lake. So it's kind of like that in-between transformation that I'm talking about, going from data lake into like this Delta Lake that you can use for analytical purposes. It's specific to Databricks technology, why we're going with Databricks this semester, plus it's part of the exam. Part of the Lakehouse Architecture Foundation. So Lakehouse architecture is used a lot. So a combination of a data lake and a data warehouse, trying to take some of that unstructured data in a data lake or less structured data and put it in a semi-structured format that allows for updating and inserting new records and so forth. And it solves the challenge of implementing ACID transactions in data lakes. So to describe ACID, I put a note in the following slide. So their ACID is atomicity, consistency, isolation, and durability. So you hear this mostly in like transactional. I don't cover it a lot in SQL because it's more of like database administration or when things are highly transactional. But atomicity is transaction is treated as a single indivisible unit. Consistency is transaction can only bring to database one valid state to another. Isolation is that they all occur in isolation from one another. And durability, once it's committed, it remains. So a lot of technical stuff, but why that's important. Be more important for real-time data or when the order of transactions that's coming in is important. They're coming in really fast. And it maintains like the integrity of the that's coming in, the order and the integrity of the data that's coming into your data source. Here's a bit of the architecture that goes into it. There are two releases, big use cases for it. So there's a Delta engine that'll take your real-time data and create a Delta Lake out of it in Azure Databricks. And then we'll learn a little bit about creating this bronze, silver, and gold Delta Lake architecture. So when we first set up Gen 2 data storage, in the first lecture, we created a raw data folder, which it'll correspond here to bronze. We have a semi-structured, or like you have your transactions and cleanup data, your process data is your silver, and then you're ready for reporting or analysis or machine learning models, gold. So you take this, run it through these processes, and continue to add it to the Delta Lake itself. So for two purposes, for real-time processing, and then your own transformation and cleaning, and then continuing to add that running transactional history to the data lake. And one of the advantages is now you can have pretty well-structured data without having like a full data warehouse environment, which can be cumbersome and difficult to change. And it's good in itself, but there are a lot of changes to schemas or data structure within business. Delta Lake provides some additional flexibility and speed to it. Okay. And we'll be building Delta Lake architecture in our next homework. Okay. So ACID transactions, we talked about that. So scalable metadata, you can add metadata to your sources to be able to find or handle data that's just huge or massive. So you could create your own partitions and be able to reference them by metadata much faster than you would if it's just a flat table and sequentially had to sort through everything. Time travel, so it's really big on you can revert to earlier versions, rollbacks, or reproduce. So it's an incremental data source that you can go back to certain points in time. That can be really valuable, especially if data is corrupted or something. And then you can store running historical in it too. Open source, unified and batch streaming. So used for your streaming services. and be a really good data source for being able to handle data sources that are producing like thousands of transactions per minute or second or whatever it may be. Schema evolution. If there's shifting schema, you can usually change or adapt it, but you can also enforce schema rules. You have your audit histories to see all of the different changes that happen to that data source. And then data manipulation type operations like in SQL or Python that you can do, so you can directly query this data source also. Okay, let's go ahead and go back to reading view. Okay, so we covered the architecture and key features. Okay, so technical implementation of data lake. This is what it's like a row column data store. So your storage format, it uses Parquet alongside of a transaction log for efficient data storage. So you keep track of all the transactions that come in. It organizes them in a way that's most efficient. And then you can query it in this way in a row column type order. If you see this, so you can see these like A1 through A5, this would be each one of the rows, B's and C's. It could be laid out in this order in the rows. This is your first record, second record, third record, and fourth record, but it may be this way in your column layout. So you could query it by column and get all this information. All right. So I think of it as a data, like it rearranges it like Tableau into like a data cube or its own row column format. Okay. So Delta log, it uses JSON files to track and maintain each one of the changes in the Delta lake. That can be important if it's highly transactional and you need to go back to a certain state. Optimistic concurrency control handles multiple writers to prevent data conflicts. That's where ACID comes in. Two transactions are nearly identical in time. They come in at the same time. Helps manage the order and the integrity of those. Seamlessly integrates with Spark and other processing engines. So you can use this in Databricks as a data source in Databricks. API compatibility, so it has APIs that you can use for data manipulation. So it has some REST APIs, but programmatic APIs you can call to. And deployment options. So you can do this on the cloud or on premise. That's a kind of promise of Azure. Okay. So exploring the advanced features of Delta Lake. Delta Lake table design patterns, you can utilize these three types of design patterns like your raw data, your transform data, your good to go data for data management. Can enforce data quality, clone and shadow operations. You can do that for versioning of data. Merge operations for upsert. So you take two data sources and compare them, and you can do upsert is upsert or update or insert. So if the record exists in a different data source, you could update it in the current one or insert it if it doesn't exist in a new one. So that's useful if you have transactional data that's constantly updated. Maybe customer and existing customer already exists in the system. So it would look for that customer on that key and it would update it But if it's a new customer, instead of updating, it would just insert that new customer record. So that can be a useful operation in managing data. Auto optimizations in Delta Lake. It's just a data source that's optimized for analytics within your data lake, or you start doing it within Databricks and for analytical purposes. And there's some performance tuning techniques also. Okay. So this might bring it down to earth just a little bit. So here's the data lake medallion architecture. So we have these different data sources. You have streaming, or you have databases and IoT and files. Your bronze would be your Delta Lake with the raw data. It's unmodified, metadata enriched, full history preserved. So this would be like your Delta Lake as it comes in, your data source more or less as it comes in, which is good because you want to keep this so you can validate, like you want to capture this raw data for cleansing and validation so you can transform it into whatever you need at any point. So you have your silver, which is your validated data. So this is like an initial transformation of cleaning and validation. And then once it's all clean, you aggregate it and optimize it into what is needed for the business case or business use, whether it's dashboards or reporting or advanced analytics and machine learning and AI models. So all of this, it's like a process that takes in this data, and through the Delta Lake, you can do bronze, silver, and gold. Okay. So here's a real-time analytics solution. So I'll move here from top down to the bottom. So first you'll ingest the data into bronze tables for real-time access. So in the Delta Lake, you'll put this in tables. You'll do data cleansing and enrichment, some type of transformation to enhance the quality and consistency, and place it in silver tables. And then you'll aggregate it for gold tables. So just like that last slide showed, you have Delta Lake operations. So there's code that you can do to make the Delta Lake operations efficient. You can create performance metrics, so performance metrics that lead to business outcomes and lessons learned in implementation, and then the process can start all over. Okay. So we'll do an example of this in our hands-on exercise. I'll also get everyone a recorded exercise here too of a video off of the internet or off of YouTube for short term, and then we'll do a recorded video of this one too, of how to do this from start to finish. So in our hands-on exercise, we'll take some crypto data out of CSV files that I have. We'll take them, and then we will go from bronze, clean them up, do some code inside of Databricks to clean them up, and then do your aggregations there also to visualize them. So we'll see this come to life here in our hands-on exercise. Okay. And in the meantime, I'll get you some videos with examples too. So Azure Database Services. So these are a combination of your relational databases, Microsoft SQL Server, MySQL, MariaDB, and Postgres. All relational, like we teach in 101, all different flavors of relational databases, but all the same as in all the properties of relational databases stand with them. The differences are usually just in implementation or functions and small little differences. So the SQL relational database and SQL language itself is primarily the same between all these databases. It's just in the implementation and functionality of is the difference between some of them, like different functions or different types of database management, things that make your Postgres database a little bit faster for transactions than Azure SQL Server. But within all these database services, so we covered these, your table we covered Azure storage. It's like your flexible store, your blob storage queue, your file shares, and your table storage in Gen 2. Azure Cosmos database is what will contain all of your NoSQL databases. So just think of NoSQL as anything that's not a relational database. It'll have a different type of data structure. So I'll often have it'll be a graph database, a key value store that's like MongoDB or some of your more popular NoSQL databases. They can be column family like tables, or your table storage is actually considered it's considered NoSQL storage. This one is a key value, but there are also some ways you can do column family, and we'll see some of the differences between them here coming up. Okay. So, but first, your relational databases, they store the highly structured online transaction processing and online analytical processing data. So in SQL 101, I explain this as data out of transactional systems, very transactional in nature, comes one after another. Maybe it's a bunch of bank transactions on credit cards, and OLAP data. So that's analytical processing. So that's data that's transformed, transactional data that's transformed specifically for analytical purposes. They have relationships across tables, queried using the SQL programming language, and then your properties. Your database is like that large container filled with database objects, like stored procedures, views, functions, and tables. So the table itself is your tabular structure. You have fields and records. You query it by fields. And then your schemas, like how your table database is organized or designed. So depending on your database management system in SQL, schema can mean different things, but oftentimes in MySQL, you just have schemas. So it's like a databases that you give your name. Maybe some of them you have a database, and you can have logical schemas within the database, how you organize these. But for relational and analytical databases, you'll see like your analytical databases as your data warehouse environments or data marts in big organizations. And then your non-SQL databases are all sorts of different, you can do all sorts of different types of data structures. Probably the biggest one's key value type. We saw that in a table, but you also see that MongoDB storing documents or storing dictionaries inside of there that have key values. So if you have the Python dictionaries, like in JSON format, you'll have key value stores. Column family. So don't have a great description of that. We'll wait for a moment. GraphDB is like I explain that as like your social media connections. It's like a graph. If you think of yourself and you think of like all of your connections and all of their connections and how they're related to each other, that's how a graph DB can store information. So one node on the graph could be you and all of your Facebook information, and then another one's a person and all of their Facebook information. So it's stored in a way, if you want to see the relationships between multiple users or second or third order users, it's an easier structure to store that in than, say, trying to do all those second and third order relationships in a relational database. And then document DB is how you store, another way of storing key value pairs. Also, let's see if I have a better description of that in the slide. But we'll cover it. We'll actually cover it a little bit more in the next slide. So we'll just go ahead and do that. Okay. All right. So that gives you a little bit of heads up into NoSQL. So your document DBs, those are actually your MongoDBs and Couch, or your MongoDB. So I always think of that as like key value pairs because it's like stored in documents or dictionaries instead of rows and columns. And then you could query them that way. So if you think about like a Python dictionary, I actually technically call that like a document because within a dictionary, you can store multiple key value pairs. So often this is like content management, blogging platforms, and e-commerce applications. So like if you're capturing a customer's transaction on an e-commerce website, maybe like a form that they're filling out to complete their transaction and their credit card information, maybe they get 7 out of 10. And then you capture all those like key value pairs on the form. You potentially store that in a document DB. You also have key value pairs. So data is stored in an array of key value pairs. So instead of being stored, so these are also key value pairs. Well, that's a key difference between these. This would be all of your key value pairs stored as one document. This would be your key value pairs stored in an array. And the key becomes a unique identifier, and the value is the data that's associated with that key. So like if you have a key that's session information, instead of having to look through all of these documents, you can store them in an array that does it in a much faster, processes it much faster, instead of having to go through all the key value pairs. Let's see, column family. So there's a link here what the column family is. Effective for analyzing large data sets, such as Internet of Things or user events. So let's go ahead and click on that. I probably put it there because I always have a hard time describing it. So a column store database is a type of database that stores data using column-oriented model. So that would be like your relational database is a column store database. Let's see, right? Column store, column family, okay. Okay, one second. So what do we have here? Column store database is referred to as column family and so forth. So the column stored database uses a concept called a key space. A key space is kind of like a schema. All the column families, kind of like tables in a relational model, which contain rows, which contain columns. So you see for each record, you'll have a number of columns in each, but it can differ in number. So I think I've had this backwards. So I was calling your relational tables like a column store, but I think that one's actually the row store, because when you filter and do like a where clause, you're selecting your rows based on your where clause. So you're selecting rows. So this is where you're selecting columns out of your column families, where some of your records will have all that information and some of them will not have that information. So here's a good example of it. So maybe Bob has his email address, gender, and his age, but Brittany only has email address and gender. And a column family can consist of multiple rows. Then each row can contain a different number of columns. Yep, because you don't have the age. Each column is contained to its row. And then you have all the unique identifiers that identify each one of those customers or each one of those keys. So you have a row key for each. I end up finding these data structures and uses. So this one that says large data sets, such as Internet of Things data or user event logs. So things that are very sequential in nature, have like a ton of customers or ton of transactions that you can index in that way. And then you have the GraphDB, which I did the best description of, ideal for social networks, fraud detection systems, or recommendation engines. So anything that has like fraud detection, that's usually like states that they enter into different states within the graph, and then they're more likely to have fraud or not, or they're your second and third order type network connections or recommendation engines. So if you think of like Spotify, this would be like, if if you like this music, other customers may also like this other music too. So it's like those relationships, and going down that rabbit hole of, if you like this music, then you might like this, and then if you like this one, you may like these 5 other songs along with it. It can be an ideal way of storing these databases or this data. And let's be honest, is that there aren't that many. I mean, you can learn these for special use cases, but why relational databases hold up the test of time is like, they're fairly intuitive, a little more intuitive, and they're captured it's very straightforward out of transactional systems to be able to capture database in this way. And not very many people have the skill sets for these NoSQL databases. Honestly, I don't use them a whole lot. I'd have to brush up my skills, use them in a professional environment. But knowing that they exist in your data, they exist in your data services in Azure or your different platforms, could help you solve a problem that's potentially extremely difficult or extremely costly to do in relational database formats in an alternative format. All right. And then Cosmos DB is a service within Azure that contains these various NoSQL databases. In this project, I don't believe that we're really going to use the NoSQL technologies. I think it might be a little much, but we will use Delta Lake and tables and so forth and parsing JSON responses. But anyway, knowing Cosmos DB, part of the certification exam, and knowing what it is, So really, Cosmos DB, they consider it its own like database as a service that contains multiple NoSQL like databases, but it also has a SQL like language to be able to query these data sources and JSON documents and so forth. So it's fully managed, supports multimodal and multi-language. It is scalable, of course, highly available, and consistency levels for the workloads that you need. And I won't cover this one too much in itself either, but I provide videos to reference for if you'd like to dive deeper. All right. So 2 tools that you can use in this class that could be really helpful to you is downloading Storage Explorer. There is a PC and Mac version of it. It can help you greatly with exploring the data lake and the structures inside of it and so forth. So what we did on our first class, we created a data lake. And then you have, it calls it blob containers, but it's a Gen 2 data lake that you create your own file structure underneath. You create your own resource and file structure. I'd like to say that it also has tables and queue storage in it that you can easily use and query. So it's all contained files and queues and data store, your file store, your hierarchical file store. It's much more user-friendly, has key features. You can manage security in it. You can drop files in here much easier. So you can just drag your files over and put it in there like it's another file explorer. And security, encryption, and so forth. So highly recommended if you can use it. Otherwise, I did find a way to browse to it through the web I believe that we do in our guided exercise. Okay. And then Data Explorer is Microsoft or Azure's way of being able to query across all of these different data sources. So you have all this data that's coming in. You have your event hubs, your IoT hubs, and so forth. And then you have your regular data, batch data. You can ingest it from the data lake and then be able to query it in a somewhat SQL-like language in Data Explorer. It actually uses called KML. It's specific to Azure or Microsoft and their data sources. It's always something that I put in Claude if I need to be able to just query it directly using Data Explorer. But you can query it. You can create things like views out of your Data Explorer to use in your applications or Power BI and so forth. Reasons you would do this, probably the biggest one is, and we might end up doing this, we'll likely do this when we do our section on real-time data. It's for real-time, being able to query real-time data as it's coming in. That's probably the number one use for it, and querying the Delta Lake. It can query a wide variety of different types of data. That's one of the useful things of it, processing structured, semi-structured, and text data. If you have high velocity, high volume data, this is a tool that you can scale up and down. That works pretty well. So just introducing it as a tool in this one that we will use later. But we introduce it here because you can query some of your data sources with this that exist in the data lake. So covered a lot of ground in this like we always do. So reviewing, we did all of the different types of cloud storage solutions, even like your types of storage are hot, cold, public, private. Those are like your blob or file storages. And Gen 2 for data analytics, your public and private clouds, the differences between those. Data warehouse versus data lake. So your data lake or your Delta Lake are stores of semi-structured or unstructured data, and sometimes structured data too. But data warehouse is like your highly structured relational database, analytical database for OLAP data, online analytical processing or analytical data. To get to that data warehouse, you have to really highly structure the data and then continue to add to it. Whereas data lake and Delta Lake and those other tools give you a lot of flexibility in storing data and then figuring out the transformations later on that semi-structured or unstructured, particularly on semi-structured or unstructured data. Your data lake house, all it is a combination between your data warehouse and data lake. That's where Delta Lake fits in. And then your Delta Lake architecture, we covered that in this class. Azure databases, we have our relational and non-relational databases. And we don't actually cover Databricks that much in this one. We don't cover Databricks in this lecture. If we go back up to the top, we did cover other data lake tools, such as Azure Data Storage and Azure Data Explorer. Okay, he got through that part pretty fast. I'm gonna give everyone a 5-minute break, and then we'll get set up for our hands-on exercise. Try to get as much through it as we can. And then I'll be here through 9:30. I'm always here from 5:30 to 9:30. So if you wanted to take your quiz at that time, if you haven't had a chance, you could do that or ask any questions about setup, or if you find yourself a little bit behind in the class, just let me know and I can help you out. So let's do 5 minutes, come back at 8:30 of this. I'll have the hands-on exercise ready to go. All right, 5 minutes, quick break, quick snack break. See you in 5. That gave me just a moment to configure it. I'll give everyone another minute or two. I'm going to grab a soda here for the last high-powered 30 minutes. I'll be back in just a minute myself, and then I'll drop some files into Slack to help us get started. Okay, be back in 1 or 2 minutes when we get started. All right, everyone, I'm back. Let me drop these files in here. Actually, moving so fast, I worked up a little bit of a sweat. And get another drink. Lectures. All right, so I have a class 3 hands-on exercise to give to everyone. And then I have a couple of data sources. Instead of doing the API integration, I have a couple of CSV files that we can get started with for the crypto data. And as you're doing that, doing homework 1, it provides a decent guide here on pulling data from these various data sources. So I have 2 CSV files. I have a fact coin history and a fact overview history. So it's like the start of a data warehouse environment where you have fact tables and dimensions and so forth. But the fact coin history will have a couple of different cryptocurrencies and it has your date in this Unix format. And then your price and trading or your total volume, trading volume, market cap, amount of liquidity available for each coin. That's maybe that's right. The date of the observation. So I got this day by day historical market caps of the market cap on that day. Is that the same value as that? Not quite. And then the symbol of the cryptocurrency is your fact coin history. And your fact overview history, that'd be your total market cap. So this would be your total crypto market cap by like this Unix date stamp total volume, total liquidity, your Bitcoin dominance, your Bitcoin, what percentage of Bitcoin versus all other cryptocurrency, your overall market cap, your date. And then I did some additional columns by hand. Like how much did the market cap change in 10 days? So going back to your machine learning class, you may do some feature engineering. So you create these variables to better help predict the future price of something. So I did some calculations where it was like the future crypto price, the total market cap. So I did like percent changes over the last 10 days, 30 days, 90 days, 200 days, so forth, doing some feature engineering to try to create a model. I think in the last class, we were probably trying to predict just the overall. Yeah, we were predicting the overall market cap and then trying to correlate that to individual coins. But that's what these two data sources are. Just to give everyone a heads up. Oops. And then I will label, I just put those in the Slack for everyone. So go ahead and download those. Walk through and data sets and CSV data sets for class 3 online or hands-on exercise. Okay. Then I'll bring this up here step by step while we're doing. Let's just go ahead and bring this up in. Let's go ahead and bring this up in Chrome, Creature Habit. So we can go to portal.azure.com. And as we go through this, if you don't have any of the or some of this set up, like please let me know. I'll slow down and wait until everyone's set up with what we're currently working on during this walkthrough. It should be a pretty good walkthrough, current walkthrough of what we currently have set up and where the setup will be useful for the first homework assignment. Having a useful setup for the first homework assignment. Okay, so class 3 online exercise, what we're doing here, right now we're just setting up the Delta Lake for, and reporting for next class on Wednesday, where we'll actually process and start populating these tables within the Delta Lake. And if we get to it in this lecture, we'll set up a SQL database for reporting. If we don't, it's not a huge deal. Mostly want to get through the Delta Lake portion of this, and then using those tables to be able to load and clean data and transform it to where we need. Okay. So here, those are live CoinWatch data sets that I gave you in those CSV files. So the prerequisites that you have your account set up. Like I said, we did have those things set up from class 1. Not too much, don't need too much of a basic understanding of SQL and Spark, but I'll help you through it. And then those sample files that I pasted into Slack. Okay. So first we want to, we already covered what these data sets are. This gives a little bit more information in your key fields and how many rows and columns are in each one. Okay, so they'll be the foundation of our cryptocurrency analytics prediction models. They'll get us started, those files, even if you haven't completed homework 1, they'll get us started with building this data Delta Lake infrastructure. Okay.
For homework 1, do we have
Yep.
to have exercise 1 and 2 done?
Exercise 1, the hands-on exercise 1 and 2.
Yeah.
You would need 1 because you would need those resources set up. But exercise 2 is more of like getting used to Postman and walking through the different API methods like post and put and get, and doing different operations on the box. So you wouldn't necessarily need to do the second walkthrough. I think it helps because it's it's more complicated than what you'll end up doing on homework 1. But if you were to just complete homework 1 and figure it out, you wouldn't need the walkthrough as much. And I'll record the walkthrough for homework or for the second hands-on exercise tomorrow. Does that answer your question?
Yeah, because I'm stuck. So I was like, damn, I can't do the homework.
Oh, you're stuck. Stuck on the second.
Yeah, and
Stuck
2.
on the second exercise.
Yeah.
Okay. We'll try to cover it. See where you're stuck here. Try to get through as much of this as we can. Okay. So everybody in the first class, we set up Azure storage account in the Azure portal. We set up Gen 2. So what this would look like is if we went to your ODSA first name, last name, you might see that here in your resources now, but if not, in your resource group, your ODSA data engineering, then you'd see ODSA data, and then your first name and your last name, and then any other resources you've created. Okay, so we'll click on that. And I was thinking that there's a way that you could view these through the web browser. So if you search here for containers, you can look through it this way. So if you do a search here, you go to containers, you can see any folders that you created. So in that first walkthrough, I created a folder called raw data and process data and curated data. If you wanted to do this through the web browser, you could just hit plus as a new container and say I wanted to create a folder called test data. It create a new folder in there. So I'd also highly recommend, like we saw as one of those tools, if you can, to download Azure Data Explorer. And then you could also view these folders this way. So you see you have your blob container, which is your Gen 2. You have your file shares, your queue data structure, and your table data structure. So if you go to blob, you can see those different folders that you've created. And you can manage security and delete and do a whole bunch of stuff through here. Get shared keys or whatever. Or you could just delete. So I'll just delete that test folder I created. But I'd highly recommend this, but I did find the way through this exercise, found the way. And then if you hit this, You see that folder's gone, but it did find a way to do it through the web browser. And that's if you go to your storage account that you created, your resource, you type in containers in search and you click on it, then you can see your Gen 2 data lake containers you've created. So this is your data lake storage, and you have your hierarchical namespace through the folders that you create. Okay. All right, so we've created that folder structure. So one thing it wants us to do inside here, these instructions, is add directory and create a folder named crypto. Oh, no, first. Select the raw data container created in class 1. I thought I was skipping a step there. Okay. So you can add directories in here. Let's call it crypto. So think of this data that we're going to upload as data that's in its raw original state that we got out of the API. So that's why we're putting it in raw data. So go crypto. And then inside of here, we'll call these folders 1 bronze for each one of these data lake architecture steps, 1 silver, and 1 gold. And they do these steps because it's a best practice. In data engineering, business intelligence, is to have go from your raw data to some type of transformation to go to your final data. And they call it bronze, gold, and silver as a best practice for engineering in your Delta Lake. Okay. So uploading your cryptocurrency data inside of your bronze folder, you can click upload to upload a file. I want to see if I can drag this. I may not be able to. So if you have your fact coin history and fact overview history, and it's not going to work in the web browser like that. So through the web browser, you do have to upload it. Then you can drop the files there. So if you hit the upload, it says upload to blob. I drop both of those files in. It says 2 files, fact coin history, fact overview history. Upload those. They're both pretty small files, so it should go fast. Then you can see those files in your raw data crypto bronze folder hierarchy with those files in it. And notice they have hot as a tier access. So it's on hot storage right now. So highly available and accessible. I believe if you wanted to change that, you could click on this file. Oh, nope, you can't change it that way. Maybe you have to change it on the folder. Oh, anyway, I'm going to keep moving through it. There is a way that you can, change tier. You could change the tier to cold if you wanted hot or cold. And they even have like a cool tier. And if you get really specific, you can have different, really be specific about your hot and your cold tiers, or even an archive tier. We'll just keep it in hot for now. They're small files, so won't take up, it won't cost hardly anything. It's only bigger as your skill gets bigger. More important to manage that. Okay, so we have that. Okay, so we've uploaded those. So we want to start implementing this Delta Lake architecture, and we could start doing this in Databricks. Okay. So is there anybody here that was setting up Databricks that still wasn't able to get their instance running? I know that we were choosing virtual machines to run Databricks with last time. I'm going to head to it, and if anybody is having that problem, let me know. Oops. So we want to go within Azure. No one just type in Databricks. Portal.azure.com. Can go to our resource. Crack open my code. So we set up our Databricks resource. And then inside of there, you can launch your workspace. Okay. So some other considerations, making sure you're running the latest runtime, which we are. And then once the cluster is running, do workspace, and then you can create your notebook and so forth. So if you have not set up your cluster yet,
Okay, that's where I'm at. I haven't set up my cluster.
you'd be able to do this if you click on compute. I've already created a compute called, I gave it my name, Jeremy Bergman's cluster. And then I have single access. We have Databricks 15.4, which is plenty. And I did the standard D3 V2 node type, which is 14 gigs of memory and 4 cores. That one worked for me. And if you did create compute on your own, I would continue with 15.4 for your Databricks version. And then I'd keep choosing these different ones that are 16 gigabytes memory and 4 cores until you get one to work that works. So you have the standards, you have the general purpose. We tried that one in the last class, which didn't work. But anything that's 16 gigabytes memory and 4 cores, it'll be enough for this class. So if you haven't got one set up, I just keep trying those until one of them works. And they'll all be pretty low cost. It'll be plenty low enough for this class. Okay, let's go back to workspace. And I go to, you could create a notebook here. We'll go ahead and create one. I already have a couple of existing ones. Create a notebook. Creates this untitled notebook. Okay. We can call this Delta Lake implementation. Okay. Okay, so in your notebook, we want to add the following cell and this following code. It's going to do a lot here as far as, I'll take you through the code. And this could potentially help you on your homework too. After part of your homework, so what your homework one is writing a notebook to be able to connect to the live coin launch API and then get the information back from the CoinWatch API. So you're sending in a request and it returns you your information. And then you save that JSON file into your data lake, and then you take that data lake, or you take that information, and then you explore it within your notebook. And then part of that is like mounting this location. So this code can help you out a little bit with that and export. This code will actually help you do that and export some of the data also. Oh, lots of code. Okay. So I'm gonna paste this in one cell, but I'm gonna take it out piece by piece in successive cells. And if you worked with Jupyter notebooks, anytime you want to create a new cell, you can do Shift and Enter. But it asked me to start first. And you see I've created this compute resource with that virtual machine. It'll ask me to start that virtual machine first. You can do that through that side, the run sign. You can select your clusters through here. So it needs to start it up. But in the meantime, I want to just do this step by step. Okay, let's go ahead and just mount this first.
Hey, Jeremy. Jeremy.
Just have to wait for the instance to start up. What you want to do is, in this code, is put your storage account name there. So what your storage account name is there. So you can go back. And while this is loading, we'll go ahead and do that. So your storage account name be ODSA, Databricks, and then your initials. And then we placed everything in the raw data. And did I call it crypto-data? Let's see. I think in raw data, I just called this crypto. So we want to start from that point. It's called mounting the storage. It's what we do in Databricks. It's like a old-fashioned Unix or Linux term to take that drive and make it accessible. And then it'll test to see if we can mount it successfully once this thing starts. Then through this code, we'll do stuff like list the files in the folder, and then we'll create each one of these tables. And I'm actually happy after this to just give everyone this notebook to let you run through it. Okay, so still waiting to start. So on the third step, we're creating our bronze tables. So this one is where we're just loading that. We're taking that CSV data and we are loading it into a Delta Lake table. We're creating a Delta Lake table. And then once you have it created in Spark, you can use this display Spark table to be able to view the data inside of that Delta Lake table. create, read market data and convert to Delta format. Okay. And then your successive steps, your silver and your gold. Okay, so do shift enter. Here's your silver up top. There's our silver. It's the same thing. They're just now casting some timestamps, creating aliases for these columns instead of having periods in them. Now we're just giving them names for the Delta table and doing things like underscore instead. We're getting rid of the name history. Then you write it to silver. Writing it to that silver folder, creating the table, and then showing the data. And then summarizing it for reporting is the last step. Okay, so I'll save this workbook once I get a chance. It's still trying to start my cluster. I should have started that during break. It seems to take a little bit of time. But the idea here is with this walkthrough is that we're taking it from the raw data that we placed, the coin data, the raw data. We're doing a little bit of cleanup for the silver data using Python and the Python notebook and Databricks. And then the last step, we're summarizing it, different ways for reporting. And then we are placing each one of these in their individual tables.
Do we also have to update the pathing? I still see crypto data.
The path, where at?
Just right, just a second ago, right to gold layer, for example. Also, the one you're right next to right now, save. It's mount crypto dash data.
What's the amount? You said, change those. Yeah, you have to change all these dashes, but the easier thing to probably do would just do all those folders as crypto dash data, or change that other one to crypto dash data. So if you went back to your data lake, to your raw data, you can easily enough go there and rename it crypto data. And we should pay attention also for capitalization because that matters in the code. Nope, it's all under lowercase, that's good and reasonable. So if I went back, oops, rename directory, crypto data. That'd be easier than just changing it everywhere in the code. Okay. So virtual machines up. Let's go ahead and run this. Invalid literal with integer base 10. Home mount crypto data is not found. Use these credentials from your cluster configuration because it's not crypto data, it's raw data. Crypto data. Run. Mount raw data container. And run. Let's try to. Method secret does not exist. Oh, because it's different error. Okay. Mount, unmount, if already mounted. Okay. Let's try to accept those changes. Method secret does not exist. Oh, because here we go. One of the things I didn't do before this class is you have a storage account key that it wants you to put in your key vault. It tries to get it from the key vault. So what I will do is record this for everyone too. I'll describe the process and let's use the remaining time for trying to get anybody working who's not up and running. Taking a little long with these lectures. All right, so the idea is that you do all this. I'll get it working. So what's gonna benefit everyone too is if I just give you this workbook, a working workbook, and direct you through how to put the key, the storage key in there, and everything to get this working. Or maybe even just putting the storage key directly in the code for now. Because you need a key to access. Basically, you're accessing the storage through REST API. So you need a key to be able to do that from your Databricks, from Databricks. So what we end up doing is going through all the data lake services, or we create those Delta Lake tables. The last gold Delta Lake tables that we create are your summarized reports. And once you have those, we set up a MySQL database that you can just import those results into, that Delta Lake reports or Delta Lake table summary that you created. You can import that right into your MySQL workbench or database that you set up for reporting. And then all of your analyst and report users can connect to it. And that part of that, we will also finish in the next lecture too. So we're spending a bunch of time getting through lectures and all the material, but we're running a little short on the working example time. So I'll record this, and I should just pre-record all these hands-on exercises. I think that's helpful. So I'll do all of that tomorrow. Hands-on exercise 2 and 3. In the meantime, as people anybody having challenges setting up the instance, the Databricks instance?
I might be having similar issues, but in all honesty, about 8:30 is when I put the kids to bed, so I've been missing the tail end of class. So I've been working through it, and your instructions are very thorough. I really appreciate that.
Yeah, if they work, that's better.
Yeah, no.
That's better.
I was about to say, there was one that I think it was like just a wording thing, or maybe they updated something since you made the instructions and it's just slightly different, but like they've been 99% spot on. It made it really easy. But I'm on the part of the first test notebook. And I don't know if I'm missing something, or because when I run it, it just does nothing. It just asks me if I want notifications every time I run it.
Go ahead and share if you wanted to
I'm getting back to
or not, or
my part. No, since you mentioned that you're usually here early, I think on Wednesday I might just pop in at 5:30 to help catch up, because like your lectures are really easy to follow, and then we get into talk about homework, and it feels like you just boot kicked me into the pool. So
yeah, I haven't been allowing for a ton of time.
So
I'm having a hard time gauging how much is too much content here versus not enough. And
no, but like I said, the lectures are easy to follow. And it might be because we've more or less had other classes that kind of sort of touched on different pieces that what you're now going through. And then I'm trying
there's always overlap between data science and data engineering.
That's what
So it helps to have all the background coming into this class too.
Because I did business intelligence, and so a lot of this harkens back to that as well. But this is much more in depth.
Yeah, I've added more depth to it for the exam too. I'm wondering,
And I don't.
It's a balance. Like, it was a lot before, but I'm adding more to it. So I really like one of the goals to be is like at the end, you could say, I could pretty much go and pass this exam, but have to assess if that's realistic or not in 8 classes, or how I do it, execute on it.
Well, I'm willing to put some money down for it, because I remember, what was it, 2021, a little bit after, the COVID. I went to go take it, and I think it was notably different at that time, because there was a 1-star, 2-star, 3-star course. And I did the 1-star. I got that certification. And then I went to go to do the 2-star, and that was leaps and bounds different. So I didn't get that certification.
Some of these are really hard. They're really hard.
But locally, it was the advent of COVID. Nobody was in the mood for hiring. That 1-star has since expired. And so I don't know the equivalency of what we're going to be taken based on back then. But I was previously 1-star Azure. Forget.
There's actually, we're doing it in reverse order a little bit. So having with Nate's guidance, pointing this class toward Microsoft exam, or if it changes to Google Cloud, we do whatever exam. But the 900, so it teaches data. I'm going to put together just a generic or like an intro to data engineering class. That one's a DP 900, and that one's easier than 203.
Okay.
So that one's easier than this one. We're skipping a step a little bit.
Well, see, I'm trying to figure the equivalency of what I took versus now, because it's been like 2.
Is it data engineering track through?
Well, see, that's the thing. When I took
Azure.
Well, I'm still talking about Microsoft Azure certificates. Honestly, I've been taking anything available to me, both at traditional college and here. And I'm starting to think that this might be the last class that I have from Omaha Data Science.
This one is like tops it all off, or?
No, I think over the last 6 months, this might be the last available course that I have. I'm saying that I might have taken all of them.
You've taken all of them. Nice. Quite the journey.
Yeah, I mean, but I will say this is the first one that's made me feel like I'm struggling, which part of me wants to give that to you as a compliment.
Well, I try to make it. Well, there's a productive struggle, and then there's just struggle to struggle, right? Tell
And
my daughter that going to high school, make sure it's a productive struggle.
yeah,
Help you through that.
yeah.
That's
No,
what I say in the SQL class. I'm just like, I'm here to help you out, but it takes some. These technical classes take work too.
yeah. Um,
Like, there's a struggle that's always involved in learning new technical skills.
yeah, and just that I've always been so worried about work, getting a paycheck, making money. I've done so many things for so many people, and to have to sit down in a classroom and see what part of what I've actually done equates to the education, and to justify the things that I've done, and did they actually make sense? Are they actually right? Is it actually what people teach? It's been really interesting and quite a bit validating. And then it's also kind of crazy because I'm so used to just brute forcing things. Like I have made spreadsheets of just crazy math to keep track of all the things, and nowadays you can type one sentence into an script, and it does the things that I spent 27 lines in a spreadsheet to do, just because Google Sheets can do it. So I did it for Google Sheets and hand it off. The math's plugged in. You just fill out the fields. And so it's simpler. It can be confusing, and part of me wants to go back to the spreadsheets.
It's my comfort zone a little bit. I start in spreadsheets a lot, actually.
Well, I mean, like
evaluating data or wrapping my head around it, doing some calculations, or it allows me to get my hands on the data.
And see, I like that so much more. And then you have a SQL database where it's all shuffled away and hidden and protected, and it's like, I get it, but like I just want to move it around. I want to use it like Legos.
Yeah, it's so much work maintaining spreadsheets. So that was like my first job. We had a data warehouse environment at First National Bank, but spreadsheet hell. And you're just like maintaining, it just grows bigger and bigger.
See, I don't mind spreadsheet hell because I know spreadsheet hell, so I'm comfortable with it.
Yeah, but eventually you're just doing stuff like trying to track down like why this link is broken, or like your references are broken.
And there's like 13 points along the trail that you got to investigate.
Yeah, you have like 20 steps.
Yeah.
That you have to do. It's like copy from A1 to C1 down to, or like A1 to C27 down to D150 to F200 or whatever. Like, and I'm like, I was always like, man, there must be like a better way of doing this. So for years, I've done things the hard way.
There is a better way. It just costs a little bit more money to get started. Okay, so actual homework. I am gonna share screen if it allows me. Oh, I got so many. Just pick a window. Come on. There we go.
I'll put this.
I just upgraded to a 2-monitor thing, and so it was a little confusing to get everything going. So this is what I keep getting. It says it's terminated. Would you like to start and run it?
Yeah, it shuts itself off automatically after
a split second.
20 minutes? No, it's not 20 minutes. 120 seconds? 2 minutes?
I thought I set it to 120. That's what your instructions say. But I click this, and it goes straight to this.
Yeah, it should do that. Can you start and attach and run? And is that working?
Okay, so that's because that's where I got stopped at. For one thing, so for most of the steps, it only took 30 seconds to a minute, but making that cluster, 27 minutes. Okay.
It looks like it's spinning and trying to start up.
Yeah, it's just that it wasn't in the instructions, and so I was trying to sit here and figure out if I needed to do the markdown, if that's what I messed up. Because this is from your day one workout of getting everything set up.
Yeah.
And I had to go back because what was it, 2 jobs ago now, I did some programming for a startup, and I had to go claw back my account from them.
Oh, you got your Microsoft account from them?
Well, it was they were the reason that I did.
Oh yeah, I know what you're saying. Yeah.
Yeah.
You signed up with it.
I signed up with it for them, and I had to make sure that clean all the payment information, all that fun stuff. So yeah, that was fun. It's good. Okay. And how long is this supposed to take?
Oh, it must have taken me while I was explaining everything, maybe 10 minutes, 10 minutes or less.
Okay. Well, with setting up the actual cluster taking 20 some minutes, I imagine this is going to be here for a while, and I'm not going to make you stare at it the whole time.
It's okay. It should start eventually in the background.
Yeah, that was really the only hiccup that I had following the instructions. So, and yeah. But that's what I'm going to keep doing, and I'll jump in Wednesday to bother you more, because I know I really haven't started the homework. I did get the quiz in, though.
Good.
I got that in at the beginning of class. I kind of panicked a little bit. I thought it was going to be late. I don't know. Like I mentioned, when it comes to the homework and the assignments, I feel like I'm behind, so I just did it.
Yeah.
So I did like the quiz, and you more or less gave us the answers during that first hour. So
yeah. I'm just gonna make the homework due on Monday too. Homework 1 and homework 2 kind of goes along with it. Homework 2 will be this class, and then creating a pipeline from the API to populate those Delta Lake tables that you create from homework 1.
okay.
So it started like setting up the pipeline. The first homework is like just setting up your environment and then writing code to connect to Live Coin Watch. That one could be a little challenging.
So I think my casual confusion is that, oh no, there's homework 1. Okay, so last week this was posted. Okay, because I spent so much time looking for anything labeled homework 1. That was my confusion.
Oop, did I mislabel it? I might have.
No, it says you sent it on Saturday.
Oh yeah, I sent it. Yeah, I was still working on it.
Okay, I don't feel bad because all last week I was freaking out that I couldn't find homework 1. Oh, okay. Yeah.
I said Friday. I'll just move it to Monday. Like the challenging part with this class, it's hard to verify if people are set up. It's easy in the SQL class.
Mm-hmm.
Maybe I should have everybody do like a screenshot.
That's really all I can think of. Is send a screenshot of your setup or your whatever page would give you the most details.
You end up doing it in homework 1 too, sending the screenshots of it.
Yeah.
So I guess if you aren't set up,
you're not going to do your homework.
Can't do the homework.
Yeah. No, I'm going to do my best to systematically go through everything. Ooh.
Okay.
Nope, just maintaining a family of 4 doesn't always give me time to do homework. That's all. Not really real.
Yeah.
Everybody has that issue, so.
I have 3 girls, yeah.
But thank you.
Know how it goes.
But thank you for your time. Thank you for staying late. Like I said, I'll pop in a little bit early on Wednesday to, at the very least, get it in my head that I'm on the right track, depending on how things are going.
Okay.
And
Always available to help too. Like, I consider myself the guide instead of trying to be the guide instead of a barrier, making class overly difficult. I try not to do that. The point of me as an instructor and successful, I feel, is if people have gained the skills and knowledge that they can go and actually use and apply.
well, like I said, I'm so used to doing things myself, learning things myself, and more or less brute forcing things myself that I don't always realize that I could stop and ask for help. And I usually just like, well, that didn't work.
I get it.
Try a different path.
I've been in a lot of environments where there's just not a lot of people to ask, but I guess you'd be surprised. There are usually people in the systems or IT or databases. You'd ask about certain things or efficiencies.
That's
Some
what
of it, sometimes you learn the hard way, or with me, I do it and then it's just like, oh, there's probably a lot better way I could have done this.
But at least you know you could do it. That's what you know, sometimes that's all.
Then I think about it, then I'm like, oh, I wonder how I would do it differently.
No, I get you. So many tales. Just, sometimes I just have to technically do it before I can look back and be like,
Yeah.
so that's where I could have done it better. You know, it's the hindsight lessons.
That's just in retrospect, yeah.
But no, you have a good night. I will see you on Wednesday.
You too. Good to have you in class, Pat.
You
What do you
too.
want to say?
Bye.
Bye. Okay, let's wrap this up. Let's go ahead and do this. Go back to my lecture. Okay. So that is the end of class 3, cloud storage and databases. The next class will be class 4, this cloud-based data processing. So this will cover all types of processing, big data processing using HD Insight and Azure. Big data processing within Databricks. We'll use HD Insight along with, can't think of the name, along with, along with Spark. Yes, so to say that one more time, we will use HD Insight along with Spark for big data processing within Databricks. We'll learn more about Azure Stream Analytics, so we'll start doing real-time data. A little bit about Azure Synapse Analytics, so that's Microsoft's data warehouse analytical offering and environment, integrated environment in Azure, and then Azure Data Factory. So Azure Data Factory is more the ETL or ELT tool to move data sets from one place to another. And then we'll dive deeper into Azure Data Factory. So real-life applications, corporate components in Deno, and monitoring pipelines. So we'll do that. Databricks, Apache Spark, and then we'll do all that in relation to Databricks and Data Factory pipeline. So that is it until Wednesday. This is Jeremy Bergman for OD at Omaha Data Science Academy. I'll see you then. Bye.